Hello everyone, good evening. So welcome to the session 12 of work, energy and power. Like in session 11, right, we have just started with the discussion of collision. So already we have seen, what is the idea of collision. Okay, so what is the idea of collision that we have covered. Then we talked about what are the different types of collisions. So we have categorized them on two bases. One is based on the motion of particles or the objects. If the motion of objects or particles involved in the collision, right, is along a straight line during the collision as well as after the collision, then we will call such a collision as what? Head on or one dimension. If they are moving in different directions, means we will call it as what? Oblique collision. Then we have also categorized the collisions based on what happens to the kinetic energy of the particles. If the kinetic energy of the particles before the collision is equal to after, then kinetic energy will be conserved, right? Such collisions we call them as what? Elastic collisions. If it is not conserved, means most of the cases what happens? The kinetic energy will be lost. Such collisions are called as what? Inelastic collisions. Okay, so we got this matrix. Totally we'll have 6 subcategories. What are these? In head-on type, means 1D, we can have perfectly elastic, inelastic, and one special scenario of inelastic. What is it going to be called as? Perfectly inelastic. What is perfectly inelastic? The loss of kinetic energy is going to be maximum. That is what is the perfectly inelastic. Then we have oblique collision. Okay, so where the motion of particles will be in different directions. Oblique, again, it can be perfectly elastic, where the kinetic energy of the particles will be conserved. It can be inelastic. We can also have a special case in that, where the kinetic energy loss is going to be maximum. That special case we will call it as what? Perfectly inelastic. We got another name for that. What is it? We can also call it as what? Plastic collision. Correct. So first we will begin with the head-on. So we'll start with the head-on perfectly elastic. So look at this. We're talking about a perfectly elastic head-on collision between two objects. Now we said, right, in case of perfectly elastic, what happens is, when the collision is happening, there will be some deformation. The objects will be getting compressed against each other, but they would actually come back to the original shape and size. Okay, so during the collision, whatever the compression happening for these objects, right, that will not be staying permanent. The objects will actually regain their original shape and size. That is why when you look at a perfectly elastic collision, right, in fact this can be a theoretical question also. We will say that in perfectly elastic collision, the kinetic energy of particles before the collision is equal to kinetic energy of particles after the collision. Means we will say that kinetic energy of the particles will be conserved. But during the collision, means during the collision time, what is going to happen? The kinetic energy will be converting itself into the energy stored for the compressing of these objects. That we can say elastic energy, like that. The best way to visualize this is, think of it. Okay, so say we have a mass m1 which is moving with a speed u1. m2 is going with a speed u2. We are taking them to be in the same direction. For here, right, to achieve collision, u1 must be more than u2. Now to better visualize how this elastic collision happens, we will think that, okay, there is a kind of a spring. It is not like there will be springs or anything, but actually what happens at the surface, when you look at the molecules, right, the molecule itself will be like a spring, molecular spring. They would get compressed, again they will regain the position. Okay, so here to better visualize is, think of it like a spring is there. Now once the contact happens, right, it is like what? The m1 is coming and touching that spring. Once it touches, think of it, what is going to happen? There will be a tendency for the spring to get compressed. When the spring is getting compressed, spring wants to push the things away. Look at this carefully. Spring force acting on m1 will be to the left. Spring force acting on m2 will be towards the right. So what happens as a result of it? Think of it. m1 is moving like this, m2 is also moving. So for m1, force acting is in the opposite direction to its velocity, so its speed is going to decrease. For m2, force acting on this is in the same direction as the velocity, so the speed of m2 will be increasing. Finally, you will come to a stage where both of them will start to go with the same velocity. By that time, the spring would have already got some amount of compression. The spring will not be in the natural state. Spring would have already got some compression. And when you reach this maximum compression state, that is when we will see that what? The objects will be having same velocity. Means here we can say there will be no relative velocity. From then onwards, what is going to happen? They will start receding away. Why? Because now there are forces acting on them, right? On m2 there is a force acting in the forward direction, so its velocity will keep increasing further. m1 there is a force acting in the reverse direction, its speed or velocity value will keep decreasing. So now what happens? m2 will start moving faster. This is slowing down. m2 will start from there onwards, the m2 will start moving faster. So once the collision process is over, that is when the spring would have come to the original shape. m2 has already started moving faster. You will see that the final velocity of m2 v2 will be what? It will be more than the v1 value. So this is how we can typically visualize how the head-on elastic collision happens with the help of a spring. But really, when the objects are colliding, there will be no spring between them. What will be there? The molecules on the surface itself, they will act like the springs. Okay. Now here the point I said, right? What are the two things that we need to remember here? One, during the collision, kinetic energy will not be conserved. Why? Because some amount of kinetic energy is changed into that elastic energy. But is it going to remain in that form? No. It will come back to the original shape, means it will give back. So that is the reason why the initial kinetic energy will be equal to final. Just like you think of a spring, right? When the spring comes back natural state, spring will not hold any energy. That's it. So this is how we can visualize a perfectly elastic head-on type of collision. Okay. Now the thing that we will be interested in is, we said that total kinetic energy of all the particles will be conserved. But as you can see, right, after the collision, what is happening? m2 is starting to move faster, means its kinetic energy would have increased. m1 is moving slow now, its kinetic energy would have decreased. Like they can ask us, what are the things that we will be interested here? We want to know what will be the final velocities. We want to know what is the v1 and v2 values. And we would also be interested to know what will be the change in kinetic energy for the individual particles. Because total kinetic energy means it will be conserved, that we know. But for the individual particles, right, kinetic energy might be changing, like you see in this case. So we want to know how it is changing. Okay. So these are the two things that we want to understand in case of the head-on perfectly elastic. And here the thing is, how do we know what is change in kinetic energy? Only when we are able to find the final velocities, right? If you are able to find what is v1, v2, that's it. We will be able to know what is the change in kinetic energy for the particle 1, what will be the change in kinetic energy for the particle 2. So ultimately it is what? How do we find the v1 and v2 values? Okay. So let us see how we can find the v1 and v2 values. For this, we will take a sample case like we are discussing, right? Two bodies m1, m2 with initial velocity u1 and u2. They are going in the same direction. Okay. They collide such that the final velocities are what? v1 and v2. So here the thing is, 1D motion means along a straight line we can have two possible directions. If you take one of them to be right, other will be left. So while dealing with the 1D collisions, right, we will have to follow the sign convention like the way we do in kinematics. What is it? If you take the velocities to the right as positive, then velocities marked to the left will be what? Negative. That is the sign convention, right? In one dimension motion, what is the sign convention we do? If you take one direction as positive, other will be what? Negative. Correct. So this is how we will be taking the general case. Now what is our objective? We want to find what is v1 and v2 values. What are we trying to find? We want to find what is the v1 and v2 values. Okay. So how do we find the v1 and v2 values? That is the question here. How do we find it? Because what do we know about this perfectly elastic head-on collision, right? Forget about perfectly elastic head-on collision. Any collision, we know the conservation of momentum principle will be satisfied. Any collision, right? Because collision is, after all, it's an independent event, or it happens because of the internal forces, correct? Now if we say conservation of momentum, what will be the conservation of momentum principle? The initial momentum is what? m1 u1 plus m2 u2. We are looking at what? Initial momentum of both the particles is equal to what? The final momentum m1 v1 plus m2 v2. Here what we will do is bring m1 onto one side, take m2 to the other side. So look at this, m1 u1 minus m1 v1 will come is equal to m2 v2 minus m2 u2. So take common m1, if you take common, right, u1 minus v1 is equal to what? m2 into v2 minus u2. Let us keep it as equation 1. This equation is coming from where? Conservation of momentum. Now we will go for the second equation, because we will know one more thing. What is it? It's an elastic collision, means the kinetic energy of the particles before the collision, what is it? Half m1 u1 square plus half m2 u2 square will be equal to what? The final kinetic energy of the particles, which is half m1 v1 square plus half m2 the v2 square. On both sides, first we can cancel the half, because half is common. Same, take the m1 terms on one side, so m1 into u1 square minus v1 square, that is equal to what? m2 into v2 square minus u2 square. Okay, so this, let us keep it as equation 2. Observe these two equations carefully. Can we get something from these equations? Look at this. We have some of the terms common. Look at the first equation, LHS. What do we have? m1 is there, u1 minus v1 is there. Look at the LHS of the second equation. m1 is there, u1 square minus v1 square is there. So look at this, what we can do. Let us do 2 by 1. 2 by 1 means what? LHS is what? m1 into u1 square minus v1 square divided by m1 into u1 minus v1. So m1 is cancelled, is equal to m2 into, what is RHS? v2 square minus u2 square by m2 into v2 minus u2. Look at this, what is u1 square minus v1 square? It is like what? What is it like? It's like, x square minus y square, right? What is x square minus y square? Means x plus y into x minus y. What is x square minus y square? Means x plus y into x minus y, correct? Now just as it is, if you substitute, right, what we'll have? u1 minus v1 into u1 plus v1 divided by, denominator is what? u1 minus v1, that will get cancelled. RHS is same thing. v2 square minus u2 square means it is also like what? X square minus y square. v2 minus u2 into v2 plus u2 divided by, denominator is what? v2 minus u2, that v2 minus u2 cancels. So finally what do we have in our hand? u1 plus v1, right, is equal to what? v2 plus u2. u1 plus v1 is equal to what? v2 plus u2. Okay, so this is what is the relation we are getting by using the conservation of kinetic energy and conservation of momentum. Now see if we can derive something out of it. So if you rearrange them, right, let us bring the u2 to the left, take the v1 to the right. What do we have? u1 minus u2, that is equal to what? v2 minus v1. If you take it to the other side, denominator, right, what is it? v2 minus v1 by u1 minus u2 is equal to 1. What is this? I think we have talked about it, right? What is this? v2 minus v1. What is v2 minus v1? Means relative velocity of separation after the collision divided by u1 minus u2. What is u1 minus u2? The relative velocity of approach before the collision. What is this ratio? This is what is the, what is this? This is the coefficient of restitution, right? For the head-on type of collision, that is how we define the coefficient of restitution. What is it? V2 minus V1 by U1 minus U2. So we are getting one important result here. What is it? For the head-on type perfectly elastic collision, right? What is the coefficient of restitution value? It will be equal to 1. What is the coefficient of restitution value? It will be equal to what? 1. Okay. So this is an important result. Okay. Now we got the coefficient of restitution, but what are we actually trying to find here? We are trying to find the velocity values, right? We are looking for what? V1 and V2 formulas. We got E is equal to 1 result, that is fine. But what we are looking for? We are looking for V1, V2 values in terms of M1, M2, U1, U2, correct? So see what we can do. We got one result. And we also have conservation of momentum equation. What is it? M1 U1 plus M2 U2 is equal to what? M1 V1 plus M2 V2. Now from this relation that we got, right, V2 or V1, any one of them. Okay, so let us say we will try to represent V2. V2 will be equal to what? U1 plus V1 minus U2, that is V2. Just take it as it is, substitute in the conservation of momentum. In place of V2, what we are going to keep? U1 plus V1 minus U2. Look at it. M1 U1 plus M2 U2 is equal to what? M1 V1 plus M2 into, in place of V2, what will come? U1 plus V1 minus U2. Okay. So now we will just have to M1 V1 plus M2 U1 plus M2 V1 minus M2 U2. Okay. So what we'll do is, because we want V1, right, let us keep the V1 terms only on the right side. Take everything to the left. Okay. So look at this. We have M1 U1 and there is M2 U1, that will go to the left. So M1 minus M2 into U1 will come. Already there is a M2 U2 on the left side. Here we have a minus M2 U2. That also will go to the left, becomes positive. So it will be what? 2 times M2 U2. That is equal to what is on the RHS? M1 V1 plus M2 V2, right? So M1 plus M2 into V1. So now we got the formula for the V1. This is an important formula, and we will have to remember this formula. If you remember the formula, means sometimes solving the questions will become easier. So we are getting the formula for what? The V1. So from here, what are we getting? We are getting the formula for the V1. So look at this. What is the V1 formula going to be? What we need to do, just we have to bring this M1 plus M to the left. It will go to the denominator. So look at this. M1 minus M2 by M1 plus M2 into U1 plus 2M2 by M1 plus M2 into U2. That is our V1 value. What is our V1? M1 minus M2 divided by M1 plus M2 into U1. Then second term is what? 2M2 by M1 plus M2 into U2. Now just by symmetric, right, we can even take the value of V1 and substitute in the equation and get it. But because they are symmetric, we can also write the formula for V2. We can write the formula for V2. See how we will write the formula for V2. So what will be the formula for V2 here? So here wherever we are getting the M1, that will be replaced by M2. Wherever you are getting U1, replace it with U2. So whatever the terms, they have to be replaced, right? They have to be interchanged. So look at this, what we are going to get. Here the corresponding term will be what? 2M1 by M1 plus M2 into U1 will come. Here the corresponding term will be what? M2 minus M1 by M1 plus M2 into U2. This is going to be our V2 formula. They will be symmetric. If you remember, one of them means just by interchanging, right? Where we get m1, keep m2. Where we get m2, keep m1, replace them. u1 will be interchanged with u2, like that. We will be able to get what is the v2 formula. So these two formulas we have to remember. So the thing is, for v1, right, the corresponding initial velocity is what u1. There we will get that minus expression will come. That's how you can easily remember. The minus expression will come in the corresponding velocity term. Similarly, look at this for v2. What is the corresponding initial velocity u2? There we will get the negative term. There we are going to get the negative term. Okay. So these are the two important results we got. These are what the final velocities of the particles after the head-on elastic collision. Okay. So look at this. So this is what is the final expression we need to remember. So v1 is equal to what? m1 minus m2 by m1 plus m2 u1 plus 2m2 by m1 plus m2 u2. As I said, right, v1, the corresponding initial velocity term will get negative. For v2, the corresponding initial velocity term is what u2, right? There we will get the negative term. Okay, so these are the velocities of the particles after the perfectly elastic head-on collision. Okay, now we can expect some questions which can be solved just by using those formulae. Two balls mass m and 2m moving in opposite directions. How they are moving? They are moving in opposite directions. They are not moving in the same direction. They are moving in opposite. Collide head-on elastically with velocities v and 2v. So they are colliding head-on elastically with velocities what? V and 2v. Find their velocities after the collision. Means after the collision we need to find what are their velocities. So how we can approach this question? Look at this. This is the scenario we have, right? So 2m and m, they are moving in opposite directions. Means if you take the direction to the right to be positive, that's what, right? Left we have to take it as what? Negative. Okay. So 2m is here, m is here. Let us call this as our particle 1. This will be taken as what? Particle 2. That's it, right? If you take one of them is particle 1 means other will be what? Particle 2. Now look at this as per the sign convention. What is our u1 value? It is 2v. u2 will be taken as what? Minus v. Why minus? Because it is on the left side. That is u1, that is u2. So we know m1 is what? 2m. m2 is what? M. u1 is what? 2 times of v. u2 is what? Minus v. That's it. So now we have to find the velocities after the collision. Means we know the formula, right? What is it? v1 is equal to what? m1 minus m2 by m1 plus m2 into u1. Just as it is, we have to substitute. So m1 is what? 2m minus m2 is m. 2m minus m means m will come. Denominator is what? 3m. So m by 3m into u1. What is u1? 2v. 2m2 by m1 plus m2 into u2. What is u2? Minus v. So you can see m will get cancelled. So what do we have here? This is 2 by 3v and minus 2 by 3v. So what is it? 0. Means the velocity of this, right, v1 value after collision, what will be the velocity of this? It will become 0. After the collision, right, what is the v1 value going to become? 0. Okay. So look at this, v1 is equal to 0. v1 means what? The velocity of 2m after collision. That's it. We got one answer. Okay, so velocity of the 2m particle after the collision is what? It will be 0. Just we'll have to substitute in that respective formula and get the answer. Okay. Now what is the other thing we have to find also? What is the velocity of the mass m? That is our second particle, right? So for that, what is the formula we have? V2 formula, right? Just this problem can be solved just by using those formulae. That's it. Problem can be solved just by using those formulae, right? So look at this. What is it? We have to find the V2 value, right? So what will be the V2? M2 minus M1. Okay. So M2 is what? M2 is the mass M. So M minus 2M by 3M into U2. What is U2? Minus plus 2m1. 2m1 means what? Already m1 is equal to m. So 2 times 2m into u1. What is u1? 2v. Divide by what is the total value? Mass 3m. So here also the same thing, right? Look at this. What is going to happen? We'll get m minus 2m is what? Minus m. So minus m by 3m into minus v. The minus minus becomes plus, m will get cancelled. So what is it? This is v by 3. So first term is what? V by 3. Look at the second term. What is second term? Here also m will get cancelled. 2 into 2 into 2. What is it? 8. 8v by 3. So v by 3 plus 8v by 3 is what? 9v by 3, which is 3v. So v2 is equal to what? 3v. Means this is the velocity of m after the collision. So what is happening here? Understand this carefully. 2m is coming to rest. The particle mass m is turning to the right. The velocity here is coming positive, means what? It is turning to the right and going with how much speed? It is going with a speed of 3v. It is turning to the right and going with a speed of what? 3v. Okay. So this is about the velocities of the particles after the collision. Okay. Let us see one more question. A moving body mass m makes a head-on elastic collision with another body of mass 2m, which is initially at rest. Okay, so here what is happening? The m is moving, but 2m is initially at rest. Find the fraction of kinetic energy lost by the colliding particle after the collision. So here what they are asking, what fraction of the kinetic energy is lost by the colliding particle? Means what? Look at this now. So let us look at this. This is the m. This is 2m. We don't even know what is the velocity with which m is moving. So let us say v is the velocity. So this one is the one that is coming and colliding. Right? That's why we call it as what? Colliding particle. So here colliding particle means what? Mass m, because that is the one which is coming and colliding. So this is initially at rest. We'll take m as particle 1, 2m as particle 2. Means here u1 will take it as what? V. u2 will be equal to what? 0. That's it, right? Now here what do we need to find? What fraction of kinetic energy is lost by the colliding particle after the collision? Okay, so here we just need to find what is v1. What is the v1 formula? What is the formula for v1? v1 is what? m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. Correct. But already what is u2? u2 is 0, right? So straight away that will be 0. Means we'll have m1, which is m, minus m2 2m, divided by 3m into u1 is what? V. So here we will see what we are getting. M minus 2m is what? Minus m. What are we getting? Minus v by 3 is coming. What are we getting here? Minus v by 3. So the velocity of the colliding particle. The velocity of colliding particle v1 after the collision is what? Minus v by 3. So here we need to understand one thing. What is the significance of this minus? Minus indicates what? Direction, right? So we are taking the right side to be positive, means what? The left side will be negative, which means after collision the m is moving to the left. Okay, so after collision m is actually moving to the left. Okay, so we'll just make a note of this formula, because these formulae we have to keep reminding ourselves. Each and every problem we are solving, right, we have to keep revisiting the formula. See, what is the way in which we will remember them? We keep revisiting them. So as many problems you are solving, right, every time you keep revising the formula once. Okay, so this is the v1 formula, right? What is the v1 formula? We got the answer, but we will have to again recite the formula one more time. What is it? v1 will be what? m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. Okay, similarly v2 will be what? Here we don't even require that, but since we are solving our problem, let us look at it. What is v2? In case of v2, the corresponding initial velocity will get the negative torque. Okay, so here we will get the negative torque. That is how we will remember it. Okay, what is it? m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. That is how we will remember it. Okay, now we are done with the question almost. What is it? We got the final velocity of the mass m, that is what? Minus v by 3. Minus indicates the direction. So for that colliding particle, what is the ke1? Half m into v square. What is the ke final? What is ke final? Half into m into what is the final velocity? Minus indicates what? Direction only, right? So what is it? It will be what? Half into m into v square by 9. Okay, so what is it? Half into m into v square by 9. Now they are asking what fraction of kinetic energy is lost. So loss in kinetic energy is what? Loss in kinetic energy means initial minus final. Half mv square minus half m into v square by 9. Correct. So what is it? Half m into v square minus v square by 9. That is the loss in kinetic energy. They are asking what is the fractional loss. What they are asking what is the fractional loss in kinetic energy of the colliding particle, right? Means what is it going to be? Loss in kinetic energy divided by the original kinetic energy. So what is the fractional loss in kinetic energy? What is it? Loss in kinetic energy divided by the original kinetic energy. So what is loss in kinetic energy? Half m into what is v square minus v square by 9? That is 8 v square by 9 divided by what is the original kinetic energy? Ke initial, half mv square. Half m cancels, v square cancels. So look at this. What fraction of kinetic energy is lost by the colliding particle? It is what? 8 by 9. Okay, so each and every time you solve a question on this head-on elastic collision, right, try to rewind these formulae once. Okay, so if you remember the formula, means most of the questions that will come on this head-on elastic we will be able to solve. Okay, now in this head-on elastic, right, we have some special cases. So we are going to discuss about actually 3 special cases. We will look at them one by one. Okay, so we know the velocities. So why I am keep on having these velocity expressions is because we have to keep seeing them as much often as possible, then only it will stick to our mind. So these are the velocity expressions that we have been seeing. Now the special case one is if the projectile and the target. See, what are these wordings, projectile and target? Like previously we used something called as colliding particle. The particle that is coming and colliding, we called it as what? Colliding particle, right? So here we are saying projectile and target. See, the one that is moving slow, assuming we are looking at this scenario, m2 is moving, m1 also is coming in the same direction, but it is coming fast. Generally what we can say is that m2 is like the target, that is what is being hit, and what is the projectile? That is our m1. So this is the common language that can be used. Whatever is moving slow and being hit by the fast moving object, right, that slow moving object we will call it as a target. Okay, but the actual meaning of these words does not have much significance. That is a general way of calling the particles. If both of them are having the same mass, means what? M1 is equal to M2. If both of them are having the same mass, look at this, what is going to happen? Look at the V1 formula, we are getting M1 minus M2, means this term itself will be what? Vanishing. M1 is equal to M2, let us say this is M. Look at this, what will be the V1 value? 2M by 2M into U2, means what? V1 is coming as U2. We'll see some very interesting result. Similarly, M1 is equal to M2, right? This also will be 0. V2 is equal to what? Look at this, 2M by 2M into U1. Quite interesting, right? What is happening? After the collision, the particles are just interchanging the velocities. Look at this, V1 is equal to U2, V2 is equal to U1. They just interchange their velocities. This is about the perfectly elastic head-on collision between two objects having equal mass. One of the practical examples of this is what we see in the case of the billiard balls. Look at this, the billiard ball, right? The white ball which is coming and hitting the blue one. Both of them are almost same mass, right? Now you see what is happening. The blue is initially at rest. Blue is what? Initially at rest. Finally, you see that the white is almost coming to rest. So we'll have some practical deviations because this is not a perfectly head-on collision, but almost we can see it like what is happening here. You can see in the visualization, the white one is almost coming to rest, means what? They are interchanging the velocities. Blue is initially at rest. What is it? V1 is equal to U2. If you call the white as 1 and blue as 2, right? If you call white as 1 and blue as 2, they are interchanging. And you will see one more thing. As the white is coming to rest, blue is now starting to move. Blue is now starting to move almost with the same velocity as the white. Means what? V2 is almost equal to what? U1. So this is the practical example that we can think of when we are trying to understand this particular special case, which is what? The perfectly elastic head-on collision between two objects of same mass. Okay, so this is the special case 1. Now we will go into the special case 2. What is this special case 2? Special case 2 is, we talked about the projectile and the target. Okay, so projectile is what? The one that is coming with a higher speed. That is what we are generally calling it as what? Projectile. And we are taking it as what? M1. And the one that is moving slow, we are calling it as what? Target. That is what we are generally taking as what? M2. If a massive projectile collides with a light target, massive means what? M1 value will be very, very high in comparison to M2. Massive means what? M1 will be very high in comparison to M2. If M1 is very high in comparison to M2, what happens? Just think about it. What is going to happen? If you look at this ratio M2 by M1, right? If you look at the ratio M2 by M1, that we can almost approximate it to 0. Negligible. Because M1 is very high, right? So M2 by M1, that ratio, wherever we see the ratio, right? The ratio can be almost equivalent to what? 0. Now we will see under this condition how the velocity values are going to get simplified. Look at this. We want to use this simplification, right? M2 by M1 we want. So what we do is we have the V1 expression, right? Denominator, numerator, divide with M1. Look at this, what we'll have? 1 minus M2 by M1 divided by 1 plus M2 by M1 into U1 plus 2M2 by M1 into U2 divided by 1 plus M2 by M1. See, wherever we have M2 by M1, that is what? 0. Means look at the first term, 1 minus 0 by 1 plus 0. That is what? Simply U1. Look at the second term. What is second term? Numerator we are getting 2M2 by M1. This is 0, right? Numerator 0 means the entire term is 0 as such. So what does he see? The heavy or massive projectile. The massive projectile, right? Velocity remains unchanged almost, because under the assumption, right, that m2 by m1 we can approximate this to 0. What are we seeing? v1 is equal to u1. Okay, so that is about the simplified result in case of the velocity of that massive projectile after the collision. Now let us turn our focus to the target. What is happening target? Poor one, it's a lighter one, right? It's a lighter target. Okay, so you will understand why I said poor when we look at the example for this. It will be an unfortunate example, but yeah, we'll look at it. What is this v2? We want to see the simplified formula for this, right? Here also we want to get m2 by m1, means divide this numerator and denominator by m1. So what is it? m2 by m1 minus 1 divided by 1 plus m2 by m1 into u2 plus 2u1 by 1 plus m2 by m1. So m2 by m1 is 0, means what? 0 minus 1, that is minus u2 will come, plus 2u1. So look at this. What are we having? v1 is equal to u1. What about v2? v2 is what? Minus u2 plus 2u1. It's a standard result. v2 is what? Minus u2 plus 2u1. That is how the velocity of the lighter target is going to be changed. Now I said we look at the example for this, right? So see the example. We have a heavy projectile which is like the lorry or the truck that is coming with a speed of 120. Is coming and hitting. Look at this mass, right? It is like 1000 kg. It is coming and hitting a person on the bicycle. The mass or a boy on the bicycle, which is what? 60 kg. So this is an accident. That's why I said unfortunate. Okay. So because we have to take some example, right? So the heavy projectile is coming and hitting the lighter target. This is the heavy projectile. This is our m1. He is hitting the lighter target. After the collision, what happens? Remember what we said. v1 will be equal to u1, means the truck or the lorry, its velocity will not change. It will keep going with what? 120 km per hour. As it is, it will keep going. Now remember, when we talk about, when we even practically see these kind of accidents, right? I don't know, we'll generally see that the bike or the cycle person, when they are hit, the general observation is what? They will start moving very fast. They will be starting to move very fast. We will see what is the reason for that. Look at what is the v2 formula. What is the v2 formula? Minus u2 plus 2u1. That is it, right? That is what we got. No. So what is it? v2 is what? Minus u2 plus 2u1. So minus u2 means what? Minus 10 plus 2 times u1. What is it? 2 into 120 means 240. 240 minus 10 means? Look at this. The bicycle will start moving with a speed of what? Suddenly after the hit, it will start moving with a speed of 230 km per hour. So he will lose the balance and then he will go and ram into something. Okay, so that is how the accident, when it is happening, right? It is going to really cause this much impact because of the principles involved in terms of the collision. Okay, but here we are assuming it to be what? A perfectly elastic. But normal collisions will not be perfectly elastic, right? There will be sound that will come, etc., etc. Okay, there will be loss of energy. So this is about the special case 2. Special case 2, what is happening? Massive projectile coming and hitting a light target. Okay, now we will go to the special case 3. It is just the reverse. Light projectile colliding with a heavy target. Look at this. M1 is less, very less in comparison to M2. If M1 is very less in comparison to M2, it is like, one of the examples is you have a stone which is going and hitting a wall like that. What is the target? It's a heavy target. Target is what? Heavy target. The ball or the stone that you throw is what? It's a light projectile. So what happens here? We will have to see. So we are looking at what? The scenario of a light projectile which is hitting a heavy target. See, if you understand these relations, right, it will be just reciprocal. I'll tell you what we are also going to get. The heavier one, whether it is the projectile or the target, the heavier one, velocity is going to remain unchanged. That we will see. So here m1 is very less in comparison to m2, right? Projectile is a light one. So here we will try to get m1 by m2. m1 by m2 will approximate towards 0. Now look at this v1. This is the projectile. We want to get what m1 by m2 means. Here we have to divide with m2. So look at this. v1 is equal to what? m1 by m2 minus 1 divided by, what is it? m1 by m2 plus 1 into u1 plus 2 times u2 by m1 by m2 plus 1. Here m1 by m2 is 0. Put it to 0. Put this to 0. So what we will get? Minus u1 plus 2u2. Almost reciprocal. Okay, so it will be coming almost reciprocal. So what is v1? It will be what? Minus u1 plus 2u2. Now similarly we can get the expression for the v2 also. As we already said, right, v2 is what? That is the heavy target. So v2 value will be what? It will not be changing. It will be same as what? u2. We will have to check it. Okay, so how do we check it? Just take this expression. So what is v2? Numerator and denominator divide with what? m2. If you divide with m2 means 1 minus m1 by m2 divided by 1 plus m1 by m2 into u2. 2 times m1 by m2 u1 1 plus m1 by m2. So here m1 by m2 is 0, right? Here numerator is becoming 0. So the second term is fully 0 now. What is the first term? 1 minus 0 by 1 plus 0 into u2. So v2 is coming as what? u2. That is what we said, right? Heavier one in both the cases, previous case as well as this case. Heavier one, the velocity will remain unchanged. The heavier one, right, velocity will be remaining unchanged. Okay. In this we can also think about one special case. Look at this. If you have a ball that is coming and hitting the ground. So this is the ground. Okay, so the ball is coming and hitting the ground. If you assume it to be like a perfectly elastic collision, the target is a heavy target, but the target is at rest. The target is at what? Rest. Now we already got the formulas, right? What are the formulas we have? v1 is equal to what? Minus u1 plus 2 u2. v2 is equal to u2. These are the two things we have got, right? Here look at this. u2 is 0. If you put u2 is 0, right, what we will get? v1 is equal to minus u1. Means after the collision, the ball will bounce back with same amount of speed but in reverse direction. And of course, since u2 is 0, v2 also will be 0. After collision also, the ground will not get any velocity or anything. Okay. So what are we seeing? If you consider this bouncing of the ball as a perfectly elastic head-on type of collision, right, where the target is a heavy target, the projectile is a light projectile. In that formula for the final velocities, if we just substitute the condition, what is the condition here? The target is initially at rest. That condition, if we substitute, means the target, which is the ground, will continue to be in the same rest. v2 also will be what? 0. But what about the v1? v1 will be coming as what? Minus u1. Means once the collision is happening, the ball will bounce back with same speed but in the opposite direction. Okay, so this is about the 3 special cases of the perfectly elastic head-on collision. Okay, so we'll just conclude this with an example. A ball is moving with a velocity 2 meters per second towards a heavy wall which is moving towards the ball with 1 meter per second as shown in the figure. So we have got a diagram for this. So this is the ball. This is the heavy. Okay. Assuming the collision to be elastic. What we need to assume? We have to assume that the collision is what? Elastic. find the velocity of the ball immediately after the collision. Immediately after the collision, we have to find what is the velocity of the ball. Okay, so how do we do it? So can we just use the relations? Already we have done it, right? This is the heavy target, light projectile. A heavy target and then light projectile. So we can straight away use that relation. Why? Because just now only we did it, right? The heavy target will not change the velocity. Projectile velocity only will be changing. Heavy target velocity will not change. What will be changing? Projectile velocity will be changing. So what is the formula we can use? So we are calling projectile as the particle 1, right? We are calling the projectile as what? Particle 1. So what is the formula we can go for? V1. V1 is equal to what? Minus U1 plus 2U2. That is the formula, right? That's it, no? So V1 is what? Minus U1 plus 2U2. So here we have to take the sign convention part. So U1 we will take it as 2. U2 will be minus 1. Why minus 1? If you take the right to be positive means left will be negative. Okay, that's it as research 2. What is minus U1 means? Minus 2 plus 2 times U2. Totally what is it? Minus 4. That's it. What is the velocity of this ball immediately after the collision? It will be what? Minus 4 meter per second. What is the importance of the minus? It is telling that it will be going in the left, because as per our convention, right side means what? Positive, left side means negative. Like this we will be able to solve such questions. Okay, okay guys, so this is about the head-on category, perfectly elastic collision and different scenarios in that. Okay, in the next class what we'll do is we'll start with the inelastic collision in the head-on category. Okay, so we have to complete inelastic collision in the head-on category, then we'll go for the perfectly inelastic collision in the head-on category. Okay, so we'll continue with the discussion about the head-on collisions in the next class.